Hello and welcome to this session, friends. My name is Yogesh Kumar. In last session on Kubernetes, we have discussed what is Kubernetes, what are the benefits of using Kubernetes. Then we have discussed Kubernetes architecture and its key components. This session is going to be on how we can create a Kubernetes cluster. We are going to cover the prerequisites, the steps required to create cluster, then how you can perform the basic cluster management. This session is going to be very basic one. If you want more detailed information, you can always refer Kubernetes documentation. So let's begin. I'm going to create a setup in this way. We are going to have one master server which will be running these particular components. After that, I'm going to have two nodes or Kubernetes nodes, node 1, node 2, which will be running kubelet service, cAdvisor, kubeproxy, and the ports. And both nodes will be interconnected using the flannel network. Again, that's not mentioned in diagram because that is a generic diagram. I will be running flannel on master node also. So you can think all these three components will be interconnected. So that's the idea. In my setup, I got three CentOS machines. And machine 1, which is kube master, that is going to be my master server, and platform is Vagrant on VMware. You can think everything is running on virtual hardware. I got VMware workstation, and VMware workstation is running CentOS. On that CentOS machine, I have configured Vagrant host, so my setup is Vagrant basically. Operating system, I got CentOS 7.3 64-bit. IP address of node or master node is going to be 192.168.1.100 and 24 subnet. Kubernetes node 1 name is kube-node-1. Again, same hardware. IP address is 101 at the end. Kube node 2 name kube node 2. Same platform, same OS, and IP address is 102. One thing we have to make sure, like our nodes, even master, all the systems are on same patch level and same operating system. That is going to make things easy, and that's recommended. Before we start cluster installation and configuration, first we need to prepare our machines. To prepare, I have documented steps. I will tell you. First of all, update your system using yum. After that, disable firewall because Docker is not always happy when you got firewall configured. So it is going to create some network troubles. I don't want to spend time on troubleshooting the firewall things or some packet row. So I have disabled the firewall. After that, disable SE Linux. Then remove the cronny. Cronny, is NTP client for the machines which are frequently powered on. For this demo, I don't want to use cronny. Instead, I am using NTP. So install NTP and enable the NTP service on all three machines. Update the etc host on master as well as nodes in the absence of DNS server. In my lab, I don't have DNS server, so I'm going to create entries manually in the etc host of every server. These are going to be my entries. Then just validate that you can ping each master node as well as the Kubernetes node from each other. That's to make sure like your servers got interconnectivity. Once your basic configuration is done, you can perform the installation. These steps I took from Kubernetes side. I have customized them little bit with requirement to my setup because exact steps were not working. I will tell you like what happened, why they were not working, what I have added. Because I'm using different hostname, and other thing, flannel was not working due to some reason, so I have figured out how to make it working. First of all, we have to create repo. Guys, one thing, Kubernetes packages like Kubernetes, etcd, flannel, these packages are available on EPEL also, but we are not using EPL repo. We are using the Kubernetes provider repository. So A reason behind, because Kubernetes is very widely developed solution, so there are many updates happening. So if we download the packages from the vendor repository, which is Kubernetes repository, that we are going to always get the fixed one or the latest one, latest packages basically. So first of all, create repo file, then install Kubernetes. I will be coming to step one technical session. I'm just giving you overview. This need to be happen on master as well as nodes, these two steps. Third step again, that need to be on master and node, where I'm specifying configuration for Kubernetes. I'm setting what is the log level, what are the privilege, which is going to be my master server. Here I'm specifying this is my master server. Here I will put some attention like why we are doing these settings. So the kube log standard error. So I'm saying log to standard error, that's true. After that I got setting kube log underscore level minus v is equal to 0. What it mean? 0 is basically debugging is on. After that I got kube underscore allow underscore priv, that's allow privilege is set to false. What it mean? Cluster is not allowed to run privileged Docker containers. After that I got setting kube master. This is the master server interface on port 8080, and this is my machine name, the master machine name. After that I am configuring Kubernetes service on master. So I'm configuring etcd. In the etcd.conf file I'm saying etcd name default. This is going to be etcd data directory, then listen client on this particular port. You may be thinking what 0.0.0.0 mean. That basically mean all the interfaces on that particular machine, because loopback IP is 127.0.0.1. Otherwise you got other IP 192.168.10.10.172. But if you specify 0.0.0.0, it means it is going to cover all the interfaces. Then this is advertised client URL. That's again Kubernetes setting. After that we are configuring API server on the master, where we are saying API server, this is address, mean all the interfaces. If you want to stick with one particular interface, just replace it with that particular IP on that interface. API port is 8080, then kubelet port is 10250, that's a kubelet default port. Then etcd server, which server to be used for etcd. Etcd is basically, as I mentioned in the last video, that's a registry where all the information is saved about cluster, its state and port state, and the nodes. So this is going to be on port 2379 on kube master. Then I'm saying what is the kube service addresses range. It is basically service cluster range. That's the default one, 10.254.0.0/16. If you want to specify any extra arg, here I'm not specifying, so it is colons only. After that we are going to start the etcd service and going to configure a network for Docker, or you can say container. So I'm starting etcd service, then I'm creating a directory which is going to contain all the information about etcd. Then etcd dctl, that's etcd controller command. Mk means make. I'm saying in this path create a directory with config. This particular config network need to be 172.30.0.0/16. I'm picking subnet 16. After that subnet length 24, so that is going to be sub division of this particular subnet, and type VXLAN. Guys, make sure whenever you pick this particular IP range, make sure that is not utilized anywhere. Otherwise, when you are starting the services, it is going to complain that particular network is already used somewhere. Because when I was preparing lab, I got stuck, because then I checked the service log. It was saying, okay, this particular network is already used somewhere. To avoid that, make sure you're picking a network which is not already allocated to some different machines in your network. After that, you have to configure Flannel service on the master as well as nodes. So endpoint is going to be kube master. As I mentioned, Master is everything. It is the brain which is managing everything. Prefix need to be kube CentOS network. You may be thinking from there this particular keyword came. That keyword came here because in etc dctl we have created a directory, and this directory is the target or containing all the information. So we are saying this is prefix of etcd means this is the part. Flannel option. I'm saying dash dash iface is equal to it1. It means for flannel networking, use it1 as the interface. That's very important, guys. Let's say on your machine you got three interfaces. Then flannel by default it don't know which particular interface to use for the communication. Make sure you are picking an interface which got connectivity with other nodes. Means let's say you got two nodes, so pick an interface which can have connectivity with second node. So Docker containers can communicate with each other and you can access. So that's the reason I mentioned iFace it1, because in my setup it1 is valid. In your setup maybe you got some different interface, you have to pick that one. Then you have to configure the Kubernetes service on the nodes. Nodes mean in my lab setup I got two nodes, node -1, node -2. So this is going to be entry. Here I'm saying Kubernetes address. This particular address port is 10250, which is the master server port. Then host name. I'm using dash dash host name dash override is equal to cube dash node dash n. N is basically you have to replace it 1 and 2. We got two servers, node 1, node 2. So you have to replace. Why I'm overriding host name? If I don't override hostname, what is going to happen? Kubernetes by default, it will pick the hostname. Let's say you got hostname test server or lab server, which is hostname, but you want to override the hostname with this particular entry or this particular name, which will be your custom Kubernetes. You can override that setting. If you don't use this setting, it is going to pick the default hostname. Sorry. Then what will be the API server for Kubernetes? As I mentioned, master is the Kubernetes API server and it listens on port 8080, so that's mentioned. No arguments for Kubernetes. After that, we have to start the services on master. I'm simply using for loop. I'm starting API server, controller manager, scheduler, and flant on the master. And on the node, we are starting proxy, kubelet, and flant, as well as Docker, as we are using Docker images. Then configuring Kubernetes on the nodes. Basically here I'm saying this is going to be default cluster because cluster is already started in last steps. And here I'm saying default context and cluster default cluster, user is default admin. So that's default configuration which I'm using. Then here, because in this command, this particular command, we have set the context. Now we have to use that context. So here kubectl config use context default context. So here we are using this particular context. Once that is done, it means your cluster is ready. So now next step is verification whether your cluster is working or not. For that you can run command kubectl get nodes. So that's something theoretical. Let me quickly jump to technical session where I can demonstrate how these steps will work. So give me a couple of seconds. Let me open my putty session. So guys, I have opened 3 putty sessions. This is my kube master, which is my master server. This is node 1 and this is node 2. As I mentioned, I have already done the pre-work, which is to update the system, disable firewall, disable SC Linux, add etc host entries, and reboot. Let me quickly show you. I will show you on one system. So my configuration is same. SC Linux is disabled, and if I show you system CTL status firewall D, it should be disabled too. You can see it's disabled. And then I have added etc host entries on all the nodes. The settings which I'm mentioning are done on all the servers. So, and I'm able to ping these machines with the name. Let me show you. I'm able to ping node 1, I'm able to ping node 2, so they looks good to me. Now pre-work is done. So next thing, we have to add the repository so we can download the Kubernetes and Flannel and etcd packages locally and install them. So let's configure repository first. For this step, you may need internet connectivity if you are using Kubernetes repository. So I'm editing a file here, and let me do it on all servers quickly. And let me add the repository target and repository configuration. So this is the information here. Let me do it quickly. Okay, so I've added repository. Basically, that's a repository configuration. Here I'm using this particular repository. This is the base URL, and I'm setting gpg check 0. I don't want gpg check. So let's install the packages. I'm saying enable repo, particularly use this particular repo, install Kubernetes, etcd and funnel. When I install Kubernetes, it automatically install Docker because that's dependency for this one, and it also gets a proxy and the other related services. So let me run this command. Let me repeat this step on other nodes. It may take a couple of minutes to finish. So on master as well as the two nodes, I'm installing these packages now, and these packages may take some time to download. As I mentioned, the download size is around, okay, we will see here, you can see 87 MB. So it may take a couple of minutes because installation is going to happen on the 3 servers. So I will wait. I'm pausing the video for that particular time duration till the time this packages gets installed. Guys, as I mentioned, Docker will automatically get installed because that dependency, you can see here, we are installing Kubernetes, Flannel and etcd, and Docker is dependency along with other packages, so that will automatically get installed. Installation is still going, so I'm again pausing this video for a couple of seconds. Another thing, while this installation is going, when Kubernetes packages gets downloaded, you can see here one package is Kubernetes node, which is basically for nodes, and the second package, which is only Kubernetes here, this one, this is basically master server. So both will get installed by default. So guys, on master as well as nodes, package installation is completed. So let's start with the configuration. One thing you may be thinking how you can check the Kubernetes version. For that, you can see here we got Kubernetes version 1.5.2. Other way you can do like kubectl, which is the command or utility provided by Kubernetes package. You can say test version. It will tell you, okay, this is a version. Okay, let's start the configuration now. So first thing which we have to do on master as well as the nodes, basically we have to configure the Kubernetes configuration. For that, file is etc Kubernetes config. Kubernetes is directory inside etc which holds the Kubernetes configuration files. So let me show you. I'm doing a web. This is the default data. I'm getting rid of default data. I don't want to discuss that in detail because I have already discussed in the theory session. You can refer or just go back and check the data if you are not clear. Let me add the entries. Save it. So I'm doing it on master as well as the servers. I've pre-prepared these files so I don't spend much time on this thing. Okay, so configuration file is there on all machines with the required configuration. Machines means master as well as the nodes. Next thing, we have to configure etcd file on the master only, because as I mentioned, etcd only runs on the master, right? So we have to configure etcd on master only. So I'm going to master. This is my master. Here I'm saying vim etcd, that's etcd default directory, and the file name which we have to modify, that's etcd.conf. This is the default data. You can see most of the entries are commented because they are default. I'm getting rid of everything, adding my configuration. Okay, so I added configuration, saving this file. I'm repeating, etcd only runs on master, so I have updated it only on master, not on the nodes. Next thing, we have to configure the API server. For that, configuration file is Kubernetes API server. I'm getting rid of the default data, adding my configuration. Okay, this looks good. Let me save it. Okay, it's done. Next thing, guys, which is basically Flannel, which is a network backbone for the Kubernetes nodes, that need to be done on master as well as the nodes. So let's quickly edit this file and do it on the nodes also. Copy pasting this stuff, So here I'm deleting the default entries, going to add my custom entries. As I mentioned, I'm using it1 for the communication. I will show you this configuration why I'm using it1. So this is on master as well as the nodes. Saving the file on master as well as the nodes. Okay, let me show you why I picked it1. If you check the network configuration on it1, I got this particular network range. Through this interface only I can communicate with the clients. So I'm using this interface. That's the reason I picked it1. If communication is happening through it0, then I can go with it0. Otherwise, they will not communicate with each other. So make sure you're picking an interface which got connectivity with other nodes. Next thing, guys, on the master, because right now I'm on master, you can see here, we have done the required configuration. So next thing, we have to start the etcd. Etcd, as I mentioned, that's registry. So service is started, and let's create a directory which is going to hold our etcd configuration. So I'm doing mkdir in the etc-dctl utility. This is going to be my path. And if I do ls-la here, you can see right now I can't access it because that's cluster registry, that's inside etc. That's not a dummy directory, basically, you can say. Okay, next thing, I'm going to create a network range. So I'm using this particular network, and that network is not utilized on my particular machines. So it is free network in my setup. So I'm going with this one. You can see here, this command finished successfully. It created this particular network. Subnet length is 24 and backend type is VXLAN. Next thing, I have to start these services on master before going to the nodes, because master need to be enabled first before going to nodes. For that, I'm just using for loop, and I have started these services. Let me go back. Meanwhile, services are getting started. I've started etcd, API server, controller manager, scheduler, Flandy. If you remember, I have only installed Kubernetes, but by default, these services will be delivered by that particular package. So this command finished successfully. All these services are active now. You can see here, green is good. And services are enabled also. You can see all the services got enabled because we did that. Services enabled, so all good. So our master is configured. And let's jump to nodes. Let's go to node 1. Here I'm going to configure the Kubernetes. For this configuration, I'm going to tell which is the proxy server. Let me do it right away, and on the other server also. So on node 1 first, I'm adding this particular configuration. node 2 also, saving file on node 2, saving file on node 1. Before save, I want to tell you again, I already explained here. I'm telling this is the API server, which is master node, and kubelet host name, basically that's node. I'm saying this is the node name for this particular machine. Saving this file. Okay, configuration is done. Next thing, I've already configured fland on both machines. Let me quickly verify. Yeah, it's got configuration. Let me check on other node. Another thing I want to tell before starting services on the nodes, let's check network configuration. I got only two interfaces, it's 0, it's 1. When I start the flan service, it will automatically allocate the IP addresses based on the range which we specified on master. Parallelly, Docker interface, which is Docker 0, that will get IP range from Flannel. Because Docker got its own custom range, but that setting will be overridden by Flannel. Flannel will impose its own IP ranges on the Docker interface. So let's start service and see what happens. So services are getting started. On client, we will be starting only limited services. Client is basically nodes. I'm using word client, which is not right. Right word is nodes, or sometimes you, as I mentioned, you can refer it as minion. Client is not right word. So what services are I'm starting? I'm starting proxy. I'm starting kubelet. I'm starting flannelD. I'm starting Docker. I'm not starting etcd because etcd is not configured on nodes. So it got started successfully. You can see finish on, let's see on node 2. Okay, node 2 also looks good. Next thing which I have to do on the cluster nodes, I have to set the default cluster, like which cluster to be used. For that one on node, I'm saying config set cluster. Default cluster is going to be kubemaster, which is my master server. After that, I'm setting the context. Context is basically what is the default context. Cluster default cluster. User is default admin. So that's something which is default. You can customize it if you got different configuration. Then I'm saying use this particular context which we just created. That's done. Let me copy paste the commands. Okay, these three commands we need to run on node 2 also. I have missed one thing which I got covered in theoretical session, but I missed here. So that configuration is in the kubelet file, which is the configuration file for the Kubernetes proxies. You see here node 1. That's fine. I'm not sure if I updated it properly on node 2 or not. So let's check that. Because I copy pasted on node 2, it need to be node 2. So as I mentioned, that's a number. If you got let's say third node, you have to say node 3 or node 4, whatever your host name on which you are running Kubernetes. So this was node 2. So that looks good. Only thing I'm thinking, because I've changed the configuration, it's good idea to restart the service. So I'm restarting the services on node 2 because I changed the configuration. It's always good idea to restart the service so new settings can take effect. Okay, services got started and all services are active. You can see on my screen. Next thing, I'm rerunning the commands like set cluster, this cluster, because it can register itself with the master node. So looks good. It means our configuration steps are completed. Next step is to validate whether the master server is able to see the cluster nodes or not. So for that we can run command kubectl get nodes. This command need to be executed on master node. From master node you will get the right data. You can see this is the node 1, this is node 2. Both nodes are ready, means they are ready or active in cluster. And this is the age, mean on node 1 services were started 3 minutes back. On node 2 we just started services 41 seconds back because we changed the configuration. But from master we are able to see the Kubernetes nodes, so master is able to communicate with the nodes. So that's something, our cluster is set up and looks healthy. And you can think how easy this one. So we have configured the cluster in a couple of seconds. Now, next thing, as a system admin or DevOps engineer, you have to manage the states of nodes, because if your master is running, like some maintenance need to happen on this particular node or this particular node, how you can do that, how you can make sure that master is not scheduling anything, let's say on node 1. Or if you want to drain, these things may be confusing for you. Let me bring one PPT where I can discuss how you can do the cluster operations for Kubernetes. To perform the cluster operation, you can use kubectl utility. So a couple of terms which we need to understand. The first term is codon. Codon means mark this particular node as unschedulable. What unschedulable mean? That master will not schedule any new build on this particular node. Second term is drain. Drain is basically whatever is hosted on this particular node, drain it. Drain means remove it. If that's under application controller, that will be spinned on the other node. But if this particular pod or any pod or any service is not configured in replication, that will be not getting replicated. Uncodon mean we are saying, okay, this particular host is ready. Let's say after maintenance, your system or your node is ready, then you can uncodon it. Means Kubernetes can schedule the things on that particular node now. If you want to check the metrics of a particular node, you can say kubectl top node and particular node name. If you want to see cluster information, you can simply run kubectl cluster info. If you want to dump that configuration, let's say you want to say what is the configuration, instead of watching that on screen, you can use dump. So that's something. Let's try these commands quickly. Let me clear my screen and start from here. So first, get the status of the nodes. Both nodes are ready. So let's make first node unschedulable, mean Kubernetes will not schedule anything on that particular node. Kubectl, as I mentioned, and codon the node name. Let's codon this particular node. You can see the message, this particular node is codon. So let's check the status now. You can see node is ready. Ready mean node is healthy, basically, you can say. But scheduling disabled, it means no service can run on this machine. Any new service, whatever service is running, those will be still running, but any new pod creation will be not happening on this particular node. So that's called codon. Drain mean drain will not happen because I don't have any pod or any Docker running on this machine. But if you want to drain, you can say, okay, drain this particular host. Right now nothing is running. You can see the message, the node is already codoned and it's drained now. Why it codoned again? Because whenever you drain a host, it makes sure that host is not candidate for new schedulings. That's to make sure. After that it gets drained. Right now the node is drained. Status would be same, it would not change because draining happened. Right now nothing will be running on this particular host at this stage. Next thing, how to uncodon a node. Uncodon mean you keep out the scheduling disabled flag, mean the system is ready after maintenance. You can simply run uncodon that particular node. It's uncodon now. Just check the status. Yeah, you can see node is ready again. Cluster info command, it will provide the cluster information. So that's useful if you want to know what is the complete configuration. It is telling the master is running on this particular node, and it is telling, okay, you can run this command if you want to get more detail. This will display the information on screen. That's a big information. Let me take you through from this particular information so you will be having idea what this particular dump mean. That's a huge information. Okay, it might be starting from here now. Okay, you can see here it is said telling this particular is the API v1 nodes. This is the resource version. This is a node 1. Node 1 got this particular self link. This is the UUID, and this is the labels. Basically, these are the default labels which I got, and this is the hostname label. So this is the configuration about nodes, what is configured, what is the memory pressure. Like here you can see message kubelet have sufficient memory available on the node. And if you got some error out of disk, this is checking disk, it got sufficient disk space, there is no disk pressure, sufficient memory available, is posting ready status, it is telling that particular node is ready, the status which we are getting. And this is the legacy host IP 1 on 1. This is the internal IP. As I mentioned, using this IP we are communicating. This is the host name for kubenote 1, and this is the machine information. It is sent to S7, and it got this particular Docker version. This is the kubelet version, and this is the Linux operating system 64-bit. That's target machine information. Then this is similar metadata for the second machine because machines are same, and in that way you can get the cluster information. You can dump it to a file if you want. So that's something how you can manage the cluster operations. If you want more detail, you can go to this particular link. I also referred this link. The reason why I'm recording this video, only thing because many guys struggle to get a path how they can start to learn Kubernetes. So that is to only give quick introduction how you can start learning. And all the material, basically most of the materials I got from Wikipedia and Kubernetes website because that's a information source. And thank you for watching this video. In next video, I'm going to cover how you can create a pod. After that, we will record another video where we'll say how you can create a replication controller and how you can do the pod operations. So that's something for next video. Stay tuned. Thank you guys. Bye-bye.